Hi student, in this video I will show you how to find domain and range for some function. Domain actually refer to the set of values of x, means the value at x exists, and range refer to the set of all value of y at y exists. So for the first function, I will show how to find domain and range of linear function. So the first example is fx equal to x, or we can write y equal to x. Okay, this is a function name fx, or we can write y equal to x. Okay, from this function, since domain refer to the set of all value of x, so if we choose x to be any value, so x from negative 2, -1, 0, 1, 2, and then we get fx equal to -2, -1, 0, 1, 2. So here there is no restriction on x, mean we can take any real value of x. So domain here equal to from negative infinity to positive infinity, and range refer to value of y or fx. So we can see that fx can be negative number, 0, or positive number. So range from negative infinity to positive infinity. Okay, next example number 2. If we have fx equal to x plus 1, so x and fx. So if we choose x equal to -2, fx equal to -1, x equal to -1, and then fx equal to 0, x equal to 0, fx equal to 1, x equal to 1, fx equal to 2, and x equal to 2, fx equal to 3. So from this, actually we can take any real value of x. So domain equal to negative infinity to positive infinity, and range, so we can see range also we can have negative number, 0, and positive value. So start from negative infinity to positive infinity. This is for linear function. Okay, next for quadratic function. So the first example, if we have fx equal to x squared, so if we substitute, actually we can substitute any values in x. We can put negative, 0, or positive, and then what the range, the outcome or the output. So if we have we put -2, -1, 0, 1, 2, so fx will become, since we have square, so the answer will be positive, 4, 1, 0, 1, 4. So we can see that the output will be positive and start from 0. So here domain equal to, we can see that value of x, we can take any real value. So from negative infinity to positive infinity, and range since start from 0, so included 0, positive, infinity. Okay, next, number 2. If we have fx equal to x squared plus 2. So actually it's same as first example. We can put any value of x, real value of x, and then x, okay, negative 2, negative 1, 0, 1, and 2, and then fx. What happened to fx? If we put negative 2, we get 4 plus 2, 6, and then 1 plus 2, 3, and then 0, if we put 0, substitute x equal to 0, we get 2, 3, and 6. So for domain, it can be any real values from negative infinity to positive infinity, and range, we can see that the minimum value is 2, so 2, positive infinity. Okay, next we move to function with a radical. What is radical? Radical means square root. So the first example, if we have fx equal to square root x. Okay, for radical, we need to know that we must put a positive value. So we have condition here, x must be greater equal to 0. Means square root must not be negative. If not, we will get a complex number. So from this condition, we will know the domain. So here domain equal to, since here x must greater equal to 0, so domain start from 0, included 0, so 0, positive, infinity, and range. So we know that domain start from 0, so if you substitute 0 into this function, square root 0 equal to 0, so range start from 0 to positive infinity. Okay, example number 2. If we have fx equal to square root x minus 4. So we know that this expression must greater equal to 0. So x minus 4 greater equal to 0, or x greater equal to 4. So from this, we know that domain equal to bracket 4 to positive infinity. Close bracket mean included 4. And then range, how to know range? Since we start from 4, just substitute 4 into this function. So 4 minus 4 equal to 0, square root 0 equal to 0. So range start from 0 to positive infinity. Okay, next example number 3. If we have fx equal to square root x plus 4 plus 2. So we have square root x plus 4 plus 2. So the first term we have radical, and then we know that the condition, the expression must greater or equal to 0, expression in radical. So we have x plus 4 greater equal to 0, x greater equal to negative 4. So for domain here, we know that domain must start from negative 4 to positive infinity. And then range. How to find range? You need to substitute this value into radical. Negative 4 plus 4 equal to 0. Square root 0 equal to 0. And then we have plus 2. Because fx equal to y equal to square root negative 4 plus 4 plus 2. So we get range equal to 2 positive infinity. Okay, next is absolute value. Okay, the first example, fx equal to modulus x. So modulus mean every value must be positive. So actually we can take any value of x from negative, 0 and positive. So here is x and then fx. From, for example, negative 1, 0, 1. If you put negative 1, fx equal to 1. You put 0, fx equal to 0. You put 1, equal to 1. So we know that domain can be any value. So start from negative infinity to positive infinity. And range, since if we put 0, is equal to 0, and other value will become positive. So range start from 0 to positive infinity. Okay, number 2, fx equal to modulus x plus 2. So from this we know that domain can be any value from negative infinity to positive infinity. But how about range? So if we substitute value x and fx, negative 3, negative 2, negative 1, 0, 1. If you put negative 3 plus 2 equal to negative 1, so you get 1. Negative 2 plus 2, 0. Negative 1 plus 2, 1. Okay, 0 plus 2, 2. 1 plus 2, 3. So range equal to, other value is positive, and we have 0 here. So start from 0 to positive infinity. Okay, next, number 3, fx equal to modulus x plus 2. So we know that x can be any real value. So domain equal to negative infinity, positive infinity. And then range. How about range? X, fx. Okay, if we put negative 2, negative 1, 0, 1, 2. So if we put negative 2, we get 2 plus 2, 4. Here 3, 2, 3, 4. So we get range the minimum here is 2. Start from positive 2, positive infinity. Okay, next is exponential function. Number 1, if we have fx equal to e power of x. Okay, same here we can put any value of x, so domain equal to negative infinity, positive infinity. But how about fx or range? X, fx. If we put x equal to negative 2, we get e power of negative 2, or we write 1 over e square equal to 0.135. And then if we choose x equal to negative 1, put x equal to negative 1, so equal to e power of negative 1, or equal to 1 over e, equal to 0.368. And then when x equal to 0, e power of 0 actually equal to 1, and then 1 means e power of 1, so e power of 1 we get also positive. So based on graph, actually this function looks like, since we get at x equal to 0, fx equal to 1 here, this is how our graph look like. So the value of, if we take any value of x, so fx will approaches to 0, but does not equal to 0. So here range equal to 0 to positive infinity, but it's not included 0. And then example number 2, fx equal to e power of x plus 1. So domain can be any value from negative infinity to positive infinity, and range you can see from table, or if you sketch a graph, e power of x plus 1 actually, when x equal to 0, fx equal to 2 here. And if from table, if we find the value x and fx, okay, if x equal to negative 2, fx equal to 1.135, negative 1, 1.368, 0 equal to 2. So from this, actually our graph does not equal to 1 but approaches to 1. So range start from 1 to positive infinity. And lastly is about rational function. How to find domain and range for rational function. So the notation for rational function, fx equal to px over qx, where qx must not equal to 0. Why must not equal to 0? If we put 0 at denominator, so this function will become undefined. Okay, let's see the first example. If we have gx equal to 1 over x minus 2, so we have condition here, denominator must not equal to 0. So x minus 2 must not equal to 0, x must not equal to 2. So we know that domain equal to from negative infinity to 2 union to positive infinity, mean does not include 2. But how to find a range? Okay, for rational function, one way to find range is actually by finding domain of the inverse function. So we just get the inverse of this function. How to find the inverse of this function? Okay, gx you can let as y. So y equal to 1 over x minus 2. So we want to find x as a subject. So y times x minus 2 equal to 1. Then expand yx minus 2y equal to 1. Yx equal to 1 plus 2y, or x equal to 1 plus 2y over y. We want to write x as a function, as a subject. So here this is a inverse function, or we can write f inverse x equal to 1 plus 2x over x. Okay, from this inverse function, we have condition that x must not equal to 0. So here we can it's actually a range for function gx. So from negative infinity 0 union 0 positive infinity. So domain of the inverse function actually refer to range of this rational function. So let's see example number 2. If we have fx equal to 2x over x minus 1, so we know that x minus 1 must not equal to 0, x must not equal to 1. So domain equal to from negative infinity to 1 union 1 positive infinity. And then how to find range? We can find inverse function of fx. So let's y equal to 2x over x minus 1. So how to find inverse function? We need to write x as a subject. So y times x minus 1 equal to 2x, xy minus y equal to 2x. So xy minus 2x equal to y, and then factor out x, y minus 2 equal to y, or x equal to y over y minus 2. Or we can write f inverse x equal to x over x minus 2. So from this we know that x minus 2 must not equal to 0, x must not equal to 2. So range here equal to from negative infinity to union to positive infinity. Okay, thank you.